And now let's talk about computer architecture. We talk a lot about how a query is executed, both on single node and in the distributed fashion, right? And here is more like general theory about the computer architecture, right? So the first type is scatter gather. So you have some kind of a leader node and has some kind of task, and it distribute to all of the nodes, all of the follower nodes, and they do the computation and aggregates the result back to the bigger leader node, and the leader node does the final calculation, right? And this is the architecture that ClickHouse follows, and is really easily bottlenecks on a single node, right? And then you have those stage by stage or MapReduce kind of architecture, right? It supports data shuffling, so it can do this shuffle and do the computation and shuffle again, right? But each one of the shuffle or the map and reduce process needs to be persisted on disk. So their wait time before a task, right? It's very stable. It's very suitable for those like long running ETL jobs, but is just not ideal for low latency queries, right? For these, you can take a look at Spark or its Photon engine, Databricks Photon engine. It follows this kind of compute architecture, right? And then you have those pure in-memory MPPs, right? It supports data shuffling and data shuffling between the memories of your worker nodes, right? So it's zero wait time, and it streamlines the execution, and it's great for sub-second joins and high cardinality aggregation at scale, right? And let's take a look at StarRocks architecture, right? Let's go back to this image. It features a storage and compute separated design. So talk about MPP. This is one thing I kind of want to debunk, is that I see a lot of people online that say MPP means storage and compute coupled design. And that's actually no. MPP actually means you can shuffle your data and scale your workload or scale your query latency with adding more nodes, right? It does not mean coupled storage and compute. Actually, StarRocks has a decoupled storage and compute design, right? And StarRocks supports data shuffling, does many distributed join strategies. So it's very great for low latency, large scale joins and aggregations, right? And also has the option to go pure in memory for data shuffling. And so it's great for sub-second query.